In this video, you're going to learn how you can use math to get better at Catan. If you're new here, my name is Olivier and I'm a certified math and physics teacher in Ontario who is currently doing a master's in statistics at Carleton University. So in Catan, or Catan, depending on how you pronounce it, you have two dice and you roll them, so I'll just roll them. Here I have 6 and 3. And you're only looking at the sum of these numbers, right? So it'd be 6 plus 3 is 9. And then the resources that you have a 9 on, you pick the card. So that's the general premise of Catan. You roll 2 dice and it's the sum. So what we're gonna look at is look at the probabilities, and then I built an app to track these probabilities and so on. So that's the cool part, is the app. Okay, so the sum of 2 dice, so that's the basic probability, right? You can never roll a 1 because the lowest number you can roll is when you have 2 ones. 1 plus 1 is 2, so that would be this cell. And then if you roll a 2 and a 1, you get 3. And then if you roll another 2 and a 1, you get 3 as well. So these are all the 36 combinations that you can have. And the sum of these two numbers, so a 6 and a 1 is 7. And it turns out that 7, there's 1, 2, 3, 4, 5, 6 ways. So 1 over 36. So there's 6 over 36 ways. So that's 1/6, and that's 0.16. So that's around like 17% chance of rolling a 7. And then it's the same thing for the numbers on the diagonal. So a 6, to roll a 6, there's 1, 2, 3, 4, 5 ways. So 5 out of 36. Same thing with 8. And as you move further and further, you have less and less chance. So for example, to roll a 12 and a 2, there's only 1 out of 36 percent chance of rolling a 2 or a 12. So it's very unlikely. I think it's less than 2% or something like that, right? We could do the exact math. So the dots that you see at the bottom of the tokens here, I think it's 4, there's 3 dots, is because there's really 3 ways to get 4. There's 1, 3, 2, 2, and 3, 1. Whereas 11, there's only 2 ways, right? There's 5 and 6 and 6 and 5. And that's why there's 2 dots. So you want to pick the tokens or the hex tiles with the most dots. That's the basic strategies. Okay, so now let's move on to part 2 of the video. This is a Shiny app that I built for Catan. And if I click let it roll, I roll a pair of dice. The first dice was 5, the second one was 3, so the sum is 8. And this is the basic probability. So that's a chart that on the x-axis, the horizontal axis, you have the sum. So it goes from 2 to 12. The most likely, that's in the dashed lines, are the theoretical probabilities. So you see that 7 has about a 17% chance, like I said, and it drops symmetrically on both sides of 7. So you could figure out all of these probabilities by yourself. And then we're gonna see as I keep rolling here, I'll just click it a bunch of times. So right now, what I'm doing is I'm rolling some dice. I rolled 17 times, and these are all the rolls. Then the plot is showing the stats, right? So for example, I didn't roll a 2 at all yet. I didn't roll a 3. I rolled some 4s. I didn't roll enough 4 to be theoretically on par here. Not enough 3, too many 6s, not enough 7, too many 8s, and so on. So another way you can visualize this is, well, like you can think about it as if it's above the dashed line, then that means it's rolling above expectation. And if it's under, it's going to be in blue. It's rolling under expectation. So it's not rolling as much as you would think it's supposed to be. But we know from the law of large numbers and whatnot that if you roll a bunch of times, that it should approximately look like this. Another way to look at these is essentially this plot, which is a Pearson's residual plot. Don't worry about the math too much. If it's under the 0, then that means it's not coming out as much. So it's the same plot. So if we just keep rolling some dice here, I'll try to get around like 60, 80 rolls. I think it's somewhere in that ballpark for Catan, a game. And we're gonna see if we keep going. I have how many rolls? 67. And you see that 2 came out more, for example, and 6 didn't come out as much. 7 was exactly on par. 9 came out a lot more. But you hear those people when you play like, oh, the nines are magic, the nines are magic. But yeah, that's the nature of probability, right? Like 9 is gonna come out more and 10 is gonna come out less than expected. But the question is it are the dice rigged? Is there some kind of magic at play? And this is what this tells you is essentially if the p-value is less than 0.05, you can think that the dice are rigged or it's very unlikely. And the smaller the p-value, the more abnormal the game is. That's one way to think about it. And the higher the p-value, like if the chart was exactly like the dashed black line, the p-value would be very close to 1. And if they were all close to 0 here, it'd be very close to 1. But if they're very far from 0, then it'd be a very small p-value. So here, I like this chart more because it's more obvious to see like, oh, the 2s that was the most abnormal number. So you can kind of get a sense of, did you play well or did you get lucky? Did you pick your numbers properly or did you get lucky? So that's an app that lets you do that. And I could add a feature to track your dice roll instead of randomly rolling yourself. But that's future improvement. I hope you've enjoyed this video. Let me know your thoughts in the comments below. I've enjoyed making this. It's pretty fun. I like applying math to stuff like that. And if you like this video, you're probably gonna like the other videos appearing on the screen. So make sure to check those out. As always, thank you for watching and I'll see you next time with Do the Work.